Congrats, buddy.
Let's look at these problems. John plans to plant X acres of durian and Y acres of rambutan. Given that the cost of planting is Rm 200 for each acres of durian and Rm 100 for each acres of rambutan, whereas the profit for each acres of durian and rambutan is Rm 500 and Rm 300 respectively. The planting is based on the following constraint. First, John has 10 acres of land. Second, John must plant at least 7 acres. Third, the total cost must not exceed Rm 1200. So to question A, write 3 inequalities other than x greater or equals to 0 and y is greater or equals to 0 which satisfy all the above constraints. B, construct and shape the region R which satisfy all the above constraints. And finally, C, find the maximum profit of sales of both durian and rambutan. So if you look at this question, John planned to plant X acres of durian. So for durian is represented by the variables of X. And Y acres of rambutan. So rambutan is represented by the variables of Y. Given that the cost of planting is Rm 200 for each acres of durian. So again, 200 is the cost of durian and Rm 100 is the cost of rambutan. Whereas the profit for each acre of durian and rambutan is 500 and 300 respectively, which means that 500 is the profit for the durian for each acres and Rm 300 is the profit of rambutan for each acres. So you can see as the first constraint, John has 10 acres of land, which means that the sum of durian and rambutan cannot exceed 10 acres of land because John only has 10 acres of land. So here X acres of durian plus Y acres of durian must be less than or equals to 10 acres. For the second inequality, John must plant at least 7 acres. So John must plant at least 7. So we can see here is at least, which means that against X plus Y must be greater or equals to 7. It cannot more than 10 acres, but at least 7 acres. The total cost must not exceed Rm 1200. So now we look at what is the cost for durian. 200 is the cost of durian for each acre. So it means that 200x plus, whereas for the rambutan is 100 ringgit for each acre. So it's plus 100y for the rambutan must be less than or equals to 1200. So actually this is the answer for question A. Write 3 inequalities other than x greater or equals to 0 and y greater or equals to 0 which satisfy all the above constraints. So here is our constraint for question A. For question B, we will construct and shape the region R which satisfy all the above constraints. And finally, we will find the maximum profit of sale of both durian and rambutan. So our objective function actually is the profit. So here, our objective function actually is the profit. So here is our objective function, let's say profit, where we represent it by the P, the symbol of P is equals to, so the profit for durian is 500, so it's 500x plus whereas the profit for the rambutan is 300, so it's 300y. So our objective function actually is the profit, represented by P is equal to 500x plus 300y. So this is our objective function. So next, we'll look at the inequality one by one. So first, let's look at the first inequality again. John has 10 acres of land. So the first inequality will be x plus y must be less than or equals to 10. The second inequality, John must plant at least 7 acres. So x plus y must be greater or equals to 7. The total cost must not exceed Rm 1200. So the cost for the durian is 200x plus 100y. 100 is the cost for the rambutan. Must not exceed means that it must be less than or equals to 1200. So here is our third inequality. Whereas for the objective function, the profit, so P is equal to 500x, where 500 is the profit for each acre of durian, and 300y, 300 is the profit for each acre of rambutan. So here is our objective function. So let's look at the solution for question A. Step 1. Just like I mentioned before, in step 1, we will interpret the problems like we have done before, this one, and form the system of inequalities. So here is our system of inequalities and the answer for question A. X plus y must be less than or equals to 10. Second inequality, x plus y must be greater or equals to 7. And the final inequality is 200x plus 100y must be less than or equals to 1200. So here is our system of inequalities. So our step 1 again is interpret the problems, just where we have done before, and form the system of inequalities. So here is our system of inequalities. Now let's look at the second step. Step 2, shade the region of feasible solutions. So you can see this is our system of inequalities. X plus y is less than or equals to 10. So we're going to use a solid line. X plus y greater or equals to 7. Also solid line. And finally, 200x plus 100y is less than or equals to 1200. So also a solid line. So for the linear inequalities, we can sketch the graph by finding the x-intercept and y-intercept. Let's look at the first inequality. So for the first inequality, let x plus y equals to 10. So at x-axis, y is equals to 0. So we substitute y with 0. So our x is 10. At y-axis, x is equals to 0. So we substitute 0 at x and then y is equals to 10. Next, we try to plot this equation. So at x-axis, x is 10. So here is the x-axis, x is 10. So here is our first point. And then at y-axis, y is equals to 10. So at y-axis, here is our y-axis, y is equals to 10. Next, we connect these points, both points with a solid line. So here is our first equation, x plus y is equals to 10. Now we look at the second equation or second inequality. Again, we let x plus y is equals to 7. We're doing the same method or we're doing the same step. At x-axis, y is equals to 0. We have x is equals to 7. At y-axis, x is equals to 0. So here, 0 plus y is equals to 7. Y is 7. So let's plot the graph. At x-axis, x is 7. Again, here is the x-axis. 7 is here. So we have the first point. x is 7. At y-axis, here is our y-axis. Our y is equals to 7. So y is equals to 7. Then we connect both points. So here is our second equation. X plus y is equals to 7. Finally, the third inequality, we let 200x plus 100y is equals to 1200. At x-axis, y is equals to 0. So we substitute y is equals to 0 into the equation. What we have here is x is equals to 6. So x is equals to 6 is at this point. Next is at y-axis. At y-axis, x is equals to 0. Substitute into the equation, x is 0. So here x is 0. Our y is 12. So at y-axis, y is 12. So here is our another point. By connecting both points, so we have the third equation. 200x plus 100y is equals to 1200. Next is we want to shade the region. So let's look at the first inequality. X plus y must be less than or equals to 10. So this red line is our equation. Because of less than 10, so we're going to shade the region below the red line. So below the red line. And our shaded region must be x greater than 0, x greater than 0, and y greater than 0. Next is x plus y greater or equals to 7. Here is this green line is x plus y equals to 7. So greater than 7. So we're going to shade the region above the gray line. So here is the second shaded region. Finally, 200x plus 100y is less than or equals to 1200. This blue line is the equation for 200x plus 100y is equals to 1200. So since this must be less than or equals to 1200, so we're going to shade the region below the blue line. So below the blue line. So here is the shaded region. So you can see that this region here is the overlap region. So this region consists of the color of red, blue, and green. So only this region from this straight line until here, and then go up and then back to this point. So this is the region this is the overlap region. Here is our graph and the overlap region. So step 3, we will determine and draw the objective function. Just like mentioned before, the objective function is the profit, where profit is equals to 500x for the durian and 300y for the rambutan. So this is our objective function. We will rearrange the function to obtain the form of y is equals to mx plus c. So we will arrange this function, the objective function, so that we can get this form, y is equals to mx plus c. So let's look at this one. So first, our profit function is p is equals to 500x plus 300y. So rearrange to obtain this form, y is equals to mx plus c. Let's say I rewrite in the form of 500x plus 300y is equals to p. So next what I do is I move 500x to the left hand side. So what I have here is 300y is equals to, here is positive 500x. When I move to right hand side, it will become negative 500x plus p. So next is I divide 300 to the right hand side. So y is equals to negative 500 over 300x plus b over 300. So you can see that now here is the form of y is equals to mx plus c. So where our m is negative 500 over x, or I can simplify this form. Let's simplify the form. Let's simplify this equation. So here is y is equals to negative 5 over 3x plus b over 300. So now here is the form of y is equals to mx plus c, where m is equals to negative 5 over 3 and our c is p over 300. As you still remember, m, the formula for the m, which is the gradient or slope, is y2 minus y1 over x2 minus x1. As you can see, the numerator is the value of y and the denominator is the value of x. Against, the numerator is the value of y and denominator is the value of x. So which means that this 5 is value of y and 3 is the value of x. So next we will draw the objective function. Now we already determined the objective function, and next we will draw the objective function. So if you look at this part, so here against our objective function, here is our objective function. Rearrange the function. What I have here is y is equal to negative 5 over 3x plus p over 300. So just I mentioned before, m is equal to y2 minus y1 over x2 minus x1. So the value in the numerator is the value of y. The value in the denominator is the value of x. Means that our y is 5, x is 3. So by looking at this graph, now we concentrate on this graph. Our y is 5. So our y is at 5. And then our x is at 3. So our x is at 3. Again, our y is 5 based on this m. Our y is 5, x is 3. Our y is 5, x is 3. So here is our line of objective function. By connecting this point, this both point, so here is our line of objective function. Next, we will move the line towards the edge or towards the end of the shaded region in order to find the maximum value. So here is our graph, the overlap region and the line for the objective function. So next step, step 4, determine graphically the optimum value of the objective function. In order to determine the optimum value, we will move this objective function line towards the end of the shaded region. So it means that we will move this line towards the edge or the border of the shaded region as far as we can go. So if you look at this motion of this line, so pay a close attention for this line. So as I move this line, so here is the edge or the border of the shaded region. So as you can see here, this is the region as the edge here, and the point here is the x coordinate is 2 and the y coordinate is 8. So this is the optimum point. Next, what we do is at the point 2 and 8. So the maximum profit is we substitute this value where x is 2 y is 8 into this profit function or the objective function. So 500 times 2 plus 300 times 8. So the answer is, the maximum profit is RM 3,400. Again, from the objective line or objective function line, we will move this line towards the end or the edge or the border of the shaded region. So this is the line as far as it can go, and here is the point. So the point is 2 and 8. After that, we just substitute into the profit function or the objective function. Here we get the maximum profit is RM 3,400.